Hello everyone. In this video I will be talking about viscosity. Viscosity is analogous to friction in the case of solids. Now introduction. Fluids offer a resistance to motion which is like an internal friction analogous to friction when a solid moves on a surface. This is called viscosity. The force exists when there is a relative motion between the layers of a liquid. For this, we can consider an example case in which oil is trapped between two glass plates. If we try to move the glass plate, we will experience a force opposing the motion. This is due to the viscosity of the fluid. Now if we replace the oil with honey, we find that it becomes much more harder to move the glass plate. The viscosity of honey is more than that of oil. Now for any layer of liquid, its upper layer pulls it forward while the lower layer pulls it backward. This results in force between the layers. This type of flow is known as laminar. When a fluid is flowing in a pipe or a tube, then the velocity of the liquid layer along the axis of the tube is maximum and decreases gradually as we move towards the wall where it becomes zero. It is shown in this figure. The maximum velocity of the fluid is through the center of the pipe. Now, this figure shows the situation of oil trapped between two glass plates. When we try to move the upper glass plate, the oil is subjected to a shear strain, and the ABCD becomes AEFD. Thus, in this strain in a flowing fluid increases with time continuously, unlike a solid. Here the stress is found experimentally to depend on rate of change of strain or strain rate. That is delta X divided by L into delta T or V by L instead of strain itself. So the coefficient of viscosity, pronounced eta, for a fluid is defined as the ratio of shearing stress to the strain rate, that is FL by VA, where F is the force applied, L is the length, V is the velocity of flow, and the A is the area of cross section. Now the SI unit of viscosity is Poiseuille. Its other units are Newton second, meter raised to minus 2, or Pascal second. Generally, thin liquids like water, alcohol, etc. are less viscous than thick liquids like coal tar, blood, glycerin, etc. The viscosity of liquids decreases with temperature, while it increases in the case of gases. Now we can see Stokes Law. Stokes Law was established by an English scientist, Sir George G. Stokes. It explains the motion of a spherical body through a viscous medium or a fluid. When a spherical body moves through an infinite column of highly viscous liquid, it drags the layer of the liquid in contact with it. As a result, the body experiences a retarding force given by F is equal to 6 pi eta RV, where R is the radius of the spherical body and V is the velocity of motion. Stokes' law is applicable only to laminar flow of liquids. It is not applicable to turbulent flow. Now terminal velocity. Terminal velocity is the maximum velocity of a body flowing through a viscous fluid. It is attained when force of resistance of the medium is equal and opposite to the force of gravity. When Force of resistance becomes equal to force due to gravitational attraction. The velocity of the spherical body becomes constant, and the velocity is known as the terminal velocity. For example, in the case of a raindrop by Stokes Law, the force which is experienced by a raindrop is given by 6 pi eta RVT is equal to mg, and m is the mass, and it is given by rho minus sigma into 4 by 3 pi r cubed, where sigma and rho are the densities of the mediums, and 4 by 3 pi r cubed is the volume of the raindrop, and g is the acceleration due to gravity. From this we get the equation for terminal velocity, which is equal to 2 into r square into rho minus sigma into g by 9 eta. Here r is the radius of the raindrop. Now Reynolds number. Osborne-Reynolds observed that turbulent flow is less likely for viscous fluid flowing at lower rates. He defined a dimensional number whose value gives one an approximate idea whether the flow would be turbulent. This number is called the Reynolds, that is Re. Re is given by the expression rho Vd by eta, where rho is the density, V is the velocity of flow, and d is the dimension. It is found that flow is streamlined or laminar for Re less than 1000. The flow is turbulent for Re greater than 2000. The flow becomes unsteady for Re between 1000 and 2000. The critical value at which turbulence sets in is found to be same for geometrically similar flows, which means the critical value at which turbulence sets in will be equal for oil as well as water flowing through similar pipes. Re can also be written as the ratio of inertial force to viscous force. So this is the end of this video. In this video, I have explained some concepts of viscosity, which includes the main concept of viscosity, Stokes Law, and Reynolds number. If you have got any doubt in any of the concepts discussed in this topic, please comment in the section below this video. Thank you.